Welcome back to the channel. This is the next episode of our basic Java programming course. Today we're going to be talking about control flow. And what control flow means is how the program will go about making decisions. So when you have multiple options in what you want to do, and that option is based on a certain input or a certain value, you will use these control flows in conjunction with conditional statements to determine what to do and when in your program. So the first one we're going to talk about is called an if statement. So if statement is a very basic check, but it is used very, very frequently in programming. So the syntax of an if statement goes as the following. First, let's get an comment if statement, and then let's get an int age equals 20. And so to write an if statement, you just type if, and then parentheses, and then here you want something that returns true or false. So some type of Boolean check, Boolean operation. And if that statement is true, then we will go into this if statement. Let me show you like this. If age is greater than 18, so age is this variable we instantiated, which is a numerical value of 20. And so we can check if it is greater than another numerical value, which is 18. And then you want open and closed curly braces. And this is the basic structure of an if statement. So if age is greater than 18, we're just going to print you are eligible to vote. Okay. So if we run this, age is over 20, so it should print you are eligible to vote. And we see down in the bottom, you are eligible to vote. Now if we were to change age to, say, 17, this conditional will now be false because 17 is not greater than 18, so this shouldn't print anything. And program is terminated and nothing is printed. So let's move it back to 20, or no, let's leave it at 17. Now the other part to an if statement is called the else block. So right after an if statement, we can write else and another set of curly braces. And this will run if this first condition is not met. So in our scenario where age is 17, this results in false, meaning we will not go into this if statement, and we will run whatever is in this else block. Let's copy this, print it here, and put you are not eligible to vote. So now we print, or we run, we print you are not eligible to vote. Now there is also something called an else if statement, which will go in between an if and an else. So here if we write else if, another parentheses, and then another set of curly braces. And right here will be another conditional check. So if age is greater than 21, actually let's do this. If age is greater than equal to 16, and then 18. And here we'll copy move this down. Like you can legally drive. So now, as long as age, actually let's do this. Let's do less than 16. You cannot legally drive. If age is greater than 18, you are eligible to vote. Otherwise, let's change this. because technically the voting doesn't really count, because here less than 16 with the driving thing changes this. But we'll leave it as is so we can see if we go into the statement. So if we change this to 15, right, you cannot legally drive because it is less than 16. We don't check this, and we don't go into this. Now, if we do, say 20, then change this back to greater than 16, and do you can legally drive, we can see that we still only get this first line printed, because this was true again, 20 is greater than 16. We also have this else if, and age is also greater than 18. So technically this is true, but this is an else if, meaning it will only run if this first one failed. But since this first one was true, we went in here, printed it, and didn't go in here. If we wanted to do a separate check on eligible to vote or not, you would do a separate if statement. So start with if all over again. If we run this now, we will get both things printed, because this is one check. Age is greater than 16, you can legally drive, and then we check again with a new if statement. So this if is true, you are eligible to vote, else does not run because this if statement was true. Now, the next thing we have is a switch case. So we'll do int day of week equals 3. A switch case is when you have a given input, and depending on what that input is, you have multiple options on what you want to do. So an if statement, really, you want to try and keep it as simple as an if else. You don't want to do if, else if, else if, else if, else if, else. You want to do an if and an else. Sometimes you only want to do a single if statement. You want to keep them very simple, so that way it keeps your program readable. But if you have a scenario where you need to check multiple options for a given input, then a switch statement is what you want to use. So to do that, you do switch parentheses the input. So input would be day of week. And then you want curly braces. And then inside here, you want case. And then this is what you want day of week to equal. So case 1. Then we will system.out.print Monday. Then you will tab over and break. And then case 2. And these need to correspond with the data type of what is being input. Let me tab this over so it's more readable. So if day of week was a string, this right here you would want to be a string for it to check as well. Copy this. Tuesday. Break. Case 3. Wednesday. Oop, hit caps lock. Break. Case 4. Thursday. Break. So what this break does is it tells a switch statement that you're done with case 1, or you're done with what you want to run in this case. You can write multiple lines underneath here, and then you need a break to let it know that you're done processing what you want to process inside of this case, and it will exit out of the switch statement. We'll do case 5. for Friday, break. And then a switch statement also has what is called a default. So just default, nothing to check. And what this means is that you want to run this if none of the previous cases you've defined are true. So if day of week is something other than 1, 2, 3, 4, 5, you want to fall into this default and run this. So if we run now, we'll get our logs from up above, and then you'll see we print Wednesday because day of week is equal to 3, so we come into this case 3, and we print this string we provided. Now, if we go to 6, which is not part of any of our cases, we should see it print weekend. We run again, and we see weekend. And this can be any number, like 1,999, doesn't matter. Still print weekend because it's not 1, 2, 3, 4, 5. If we put 1, we'll print Monday. So these are your two main ways to have control flow by checking what a value is or checking a Boolean to see if you need to go down a certain path in your program or not. Now the next section get some logs, switch statement is loops. So there are a couple different loops that you need to know for just basic Java programming. The first one is a while loop. Second one is a for loop. And then the last one is a do while loop. So we'll go over the first one. And we'll create a new int called min value equal to 5. So for a while loop, this is something that you want to run this block of code anytime this Boolean is met. So it's also you also want to return a Boolean. So while min value is less than 10, and then like the others, open and closed curly braces. So as long as min value is less than 10, we want to perform the code or run the code that's in here. So if we just do system.out.print iteration and then min value. And actually, let's change this to 1 and this to 5. And then after we print that, we want to do min value plus equals 1. So this is that compound assignment we discussed in a previous episode. So what this is going to do is add 1 to the value that's already in min value and reassign it to the min value variable. So after this runs once, min value will now be 2. And then this will keep increasing as we run through this block of code until this is no longer true. So until min value is greater than 5, not less than 5. So let me run this, and we should see 4 log statements, iteration 1, iteration 2, 3, and 4. Because we started with 1, and it was less than 5, we printed, we increased the value of this min value object, and then once this value was equal to 5, this was no longer true because 5 is not less than 5. If we were to make this less than or equal to 5, we would see it print out iteration 1 through 5. But in this case, 1 through 4, 4 is the last one that's less than 5. This is a basic while statement, and this is what you want to do. You can use this for many things. You use it for checking a value. If you want to perform an operation as long as a value is less than or greater than a set constant you have, you can use it that way. Another way is if you have a separate check inside this block that operates on a Boolean and can turn that boolean to false when you reach a certain point, once you've ran this block of code enough, and then that check here can be a check on that boolean. So while true, do this until that value becomes false. Another thing we have is a for loop. So for loops are very useful mainly for looping through things called arrays, which we will go into in a later episode. But if you have a list of things you want to do, or you know that there is a set number of times you want to perform a block of code, is when you would use a for loop. So we have for, which is how you start this, just FOR, then parentheses, and then here is how you set up a for loop. So you want to do int I equals 1 colon I less than 5 colon I plus plus, and then open and curly braces. So what does this mean? So these are the parameters that you will provide for this for loop function. We're going to give it a starting variable. So we're going to instantiate a new variable called I, which is an integer. We're starting it with the value of 1. This middle section is the conditional that it will check to see if this for loop needs to stop running. So as long as this right here is not met, this will run. And then this I++, we haven't seen this yet, but I++ is another way of doing compound assignment like we have here. So it's a shorthand way of telling it to add 1 to that value. So where we did right here, min value plus equals 1, this is doing the same thing. Every time this runs, min value will increment itself by 1. This is the shorthand way to do it. Oh, ultra shorthand way. Technically, this is shorthand. This is even shorter. So just I++. So every time this block of code runs, it will increase I by 1 for you. You don't have to write that line of code. So we can take this log here, put it in here, and run, and we should see the same thing. Oh, and I printed min value again, not I. Sorry. So here we see iteration 1 through 4 from our while loop. Then we see iteration 1 through 4 again from our for loop. So this is running every time. So it starts at I equal to 1, it runs, or I is equal to 1, it checks if this is true. If it is, it runs. Once that runs successfully, it will increment I by 1, run again, and check again. So that now I is 2, I is still less than 5, 2 is less than 5, it'll run again. Then it will increment I is now 3, it'll run again. 3 is less than 5, that's true, so we'll go in the block. System.out.print, iteration plus I3, one more time for 4. Last time it will try to run again, but this condition is now false, and it will break out of this for loop, and it'll be done processing. The last one we have is called a do while loop. It's very, very similar to a regular while loop. The difference being that this will always run a minimum of 1 time. The while loop will always run, or can run 0 times. So if min value is never less than 5, this while loop will never be true and will never run, and it'll just go past it. A do while loop runs the block of code first and then does a check. So we'll actually use min value again. And so to show this, so we'll do a do while then while min value is less than 5. Or sorry, we'll do greater than 5. So, you see this while statement, min value greater than 5. Well, min value is, actually let me use a different variable because this will have incremented, this will run. Call this max value just for something different. So while max value is greater than 5, it's going to do this. However, even though max value is not greater than 5, this do is stated prior to the while. So it's going to do this one time, then it will check this while condition, and if it's true, it'll run again. If it's false, it won't. So let's do iteration. Up here, let's do for iteration, and then while iteration. So we see the differences. So let's run. Oh, and I have a space there, and that's annoying. So here, we see, we do our while loop, we do our switch, we do our ifs, we do our for iterations, and then we see do iteration 1, but then no more. Because it does this block of code, and then it checks the value. Now, if we do max value less than 5, and do this max value plus plus to increment it, now we should see this run all 4 times. So we run again, and here we have do iteration running 4 times. It runs it once, then it checks. It'll be 2 by the time it checks. And then it runs, checks again, up until we get to check it against the last time, which will be 5. So those are the 3 main ways to do a loop where you do the same thing, same block of code over and over again, dependent on some type of conditional, because you have to have a break case or a default case, something that breaks out of the loop. You don't ever want to have code where this is always true, because if this is always true, then you have no way to exit that. You'll have to manually close the program or exit it out, or it'll actually end up crashing eventually. Java will catch itself and it'll realize it has this infinite loop and it will shut itself down. So you don't want to do like while true here. You see it throws an error right here because we have this unreachable code, because since we're manually passing in true, this will always be true, meaning we will continually run this while statement indefinitely because this case never changes. So we will never have a false check here. We will never exit and make it down to this for loop. So before we even run it, it tells us that, hey, you can't do this, you don't want to do this, or if for some reason you're doing this on purpose, everything that comes after this is pointless. It will never be reached. It will never be ran. Less than 5. So those are the main ways you have in Java to provide control flow to your program. Provide ways to choose the path to take when you need to make different operations based on a certain value or based on a certain condition. So, as the end of the end of this episode, I do have just one coding exercise this time. Uh, I know it's kind of a lot in one episode, multiple things you can do, but this will be a really simple exercise. Is an age classifier. Write a Java program that takes an age as input and classifies it into different categories. So if age is less than 0 or greater than 120, print invalid age. If age is 0 to 2, print infant. If age is 3 to 12, print child. If age is 13 to 19, print teenager. If age is 20 to 59, print adult. If age is 60 or older, print senior. Now, you'll be doing this by just passing in an age that you choose, but once you've written it, make sure you pass in something in each of these categories to make sure that you're printing the right thing. And do this in, you can, I would do this in a hint using if and else ifs, but do it however you think you need to do it, and try and make sure that when you pass in each of these categories, it prints what is necessary. So that's it for this episode. If you enjoyed, if you learned a lot, like the video, subscribe so you don't miss the next episode. As always, if you have any questions or comments, leave them down in the comment section below, and I'll make sure to read them.